Hello, all. So I am just gonna start a bit early today. Um, the beer I'm gonna start with is actually called Zilla IPA, White IPA. There's a other Zilla from the same brewery, Rebellion in Regina, Saskatchewan. Um, and the content of today, I'm actually gonna be uh creating a PCB of that schematic. Well, we'll see how far I go. I want to create a PCB using that schematic. Um, just because then it's gonna be make it easier for me to go and create different things. Well, sorry, I'm rambling a bit. It will be easier for me to go and make some to test out circuits, OpAmp circuits on the bench. I just want to check something quickly. Yeah, and if you have any questions while I'm sort of doing this, just let me know. Yeah, let's get going. I'll X out of here for now, and we will go open KiCAD here. Now I have selected two PNP, a PNP transistor and an NPN transistor that I'll be wanting to use. I don't think they're the same ones as in that oh, yeah, it keeps on saying that I just first started using this KiCAD 9, but I swear I've used it before. Anyways, let's go TIP 42C. Include it. And then 31. Let's just go transistor. So we're in the transistor BJT. And I just want to look. We want a power transistor. There we go. Some more. I want a TO220. There's one. Got an NPN, yeah. Sorry, I'm just wanting to make sure we get the right one here. Here's more Darlingtons. I don't want a Darlington one. Let's just look at this one. Because we can rename it in my schematic after, so keep that there. This is the one we're trying to put in. And it will open up its data sheet here. Yeah, we don't want that one. I'll just take TIP. Go 41. Yeah, here's that. That would mean one. Yeah. Might as well go with that one. And I might actually. We got those two there anyways. Let's just look. TIP 41. I might order both actually. Oh, it says it's not available. That's odd. Let's go back here. And there's one. So I may actually, I'll add this to my cart actually. 10 of them. And let's go back to our circuit. So they use 31C and 32C, which is what I was about to use for one of them, I guess. It's odd. Again, I haven't done too much research on it yet. I certainly will later. Let's just keep on adding stuff. We'll add next, I think, would be the 5532, and I am in fact using the 5532. Set this over here. And I want to put you, might as well have them there. Actually, let's just go right click. And I think I can go properties and unclick that visible. Might as well do that with this one too. Properties and visible. Okay. Let's just see. I think it said E. Yeah. So the shortcut there is also E. If you're looking for a shortcut. Now I'm pressing M. Okay. And I'll just keep this one over here. I'll keep it visible. I'll just keep it over here. And then I forget what is the shortcut for no connect flags. Q. So yeah. Always forget you have to. So click and delete that. Because none of those are going to be connected. Okay. So now we got all of that. And also, if you have any questions, just shoot them in the chat. I'll try to pay attention. Okay. Now I'm going to place our resistors. And got those two resistors there. Now we might as well place capacitors. I think it actually will use a polarized capacitor here. Mostly because it's asking the schematic I'm working from that other channel again. Asks to use fairly large capacitances, 100 microfarads. We'll better use the polarized one because I'll be using aluminum electrolytic capacitors. So there we go. Now, that's maybe there might be some people new in the thing. This is the schematic I'm working on. It is from a different channel again. Here, it's a drone. Yeah, drone bot workshop. It is. I do have a link
current rate
to that person's channel in the comments, or not comments, I guess, or description. But anyways, that's where that's coming from, and this is the circuit we're building. Back, and then I think I basically have everything placed now. Now I guess we should put some labels here. Let's say positive. Over here, negative. Yeah. Now let's just start wiring. And you see what happens. Guess I can comment some on what is actually happening in this circuit. Is that when, like you see, we're applying. Sorry, I got sidetracked there. So I have a what's it called, a power supply that does have a ground, so I can put the ground where I sort of want to, and it will supply the power across the negative and the positive terminal of what it's supplying. This is the little breadboard version of this circuit that I made. So here's the ground one, and that's going to be coming out here in the middle. And then this is the positive and the negative. So in this configuration, the positive, we're going to make both of these 10K, by the way. That means that this voltage, these two voltages here, will want to be in the middle of whatever voltage differential we apply here. And the way they'll do that when we have the negative in the middle is it will basically make this one like V divided by 2. So in my case, I set it at 15 volts, like V equals 15 volts. So then it was 7.5 volts here, and minus 7.5 volts on this side. Now, if you watch some of my future videos, you'll see I'm still experimenting with OpAmps a lot. So in maybe a couple months, I'll be able to give a better explanation of how this circuit works. But I sort of understand the gist in my head, at least. But I should honestly just get going to making this circuit, since the goal, I just want to have a nice PCB on the bench instead of this messy breadboard. And then really, breadboards are just to have around, not not for permanent installations. At least in my opinion, I mean, you can use them for permanent installations, but I like to create a PCB for that. If I do, yeah, the shortcut W, I can make a wire. Go back here. I'll just move this over a bit. Is there any questions or comments? No? Okay. I will keep on trucking here. So we get our schematic made out. And then just extend this out. Okay. What I have to do here is actually cancel. Escape. A. So I'm gonna add ground label right there. So you see what I was saying again. Basically, we have this is where I connect my power supply, positive and negative terminals. Then I connect its ground here. And what I'm probably going to do now is actually make a connector right on this side. So like if this was the PCB, there will be one connector here and another connector over here. And then the connector over here will be for the power supply. The connector over here will be to go to the whatchamacallit, the breadboard, I guess I'm working on, whatever circuit I'm testing, that I want a positive and a negative voltage. This isn't actually a bad beer. It's again that Zilla IPA from Rebellion. Okay. Speaking of terminals, let's add screw terminals. Put one there. Then we may as well actually put another identical one on this side. It will raise the cost of the board some, but I think that it will be worth it. And let's just see. Control V, Control C, Control V. Then Control C, Control V. There. And we'll do the same on the other side. Actually, might as well just connect you to there. C, Control V, Control C, Control V. There we go. Oh, we got something pretty key to wire over here. There we go. Okay. Now both these are going to be 10Ks. Okay. So now I want to use, I'll start assigning footprints here now. Oh, here. First, how about let's go back to my digit key. Oh, I just saw my shopping cart. 55, 32. I want to use, yeah. Okay, yeah, this is the one I purchased in 2024. I just used some, actually. But this is what I want. So, manufacturer part number. Just go in here, edit it. Value, good. Just hit MFG, part number. There. Now we'll add another field digit key. You can even add in now, and I did this once. I added in the datasheet PDF. You can embed them now. But I think that I don't need to do that. But anyways, now let's try. We better go DIP here. What do they even call it? I forget. Mountain 8 dip. That's what they call it. 8P DIP. Okay, no, DIP. No. That doesn't look right. This X out there and go scroll down. Through the whole IC packages. No. Nope. I don't even know what that looks like. Oh. There. I believe this is the one I'm looking for. Row space in 7.62 millimeters. Let's just check. We can go to, again, the data sheet. Of course. And this is information's usually all the way at the bottom of the data sheet. Might have went too far. Yeah. It's a layout example. No. I didn't go far enough. That's the tape and reel information. Ah, here it is. Footprint information. This is for the surface mount one. Here it is. Yeah, so see here. Yeah, 7.62. That's what we are wanting. Then the distance between them is 2.54. We could check that. I'll just check that in the thing. I forget how I can go in. I think they changed it in KiCAD 9. I don't know what that does. I just want to check the distance between the two leads, not between the rows. But I'm sure that that's fine there. We've got that one placed. Then the biggest thing will be is trying to find a new screw terminal. Let's do these ones next. I don't know if I'm gonna buy new 10Ks. I have lots of 10K resistors. Which I mean, who doesn't have lots of 10K resistors? Go resistor, THT, axial. There, this is the one I'm looking for. Now, don't usually go for a diameter long or being that long. I think I usually go with. That doesn't look right. Could be though. Let me see. Just give me 1 second. I got my trusty so I want to go probably at least 9. Yeah. 9 millimeters in length. I think. Oh, that's the pitch is what I'm looking at. Let's do this one. Yeah. Yeah. Pitch 10 millimeters. I think that's right. For that, I'm not going to put in a specific one. Because, like I said, I don't think I'm going to buy more. Because, I mean, I have lots. There they are. Again, Zilla IPA, the beer I'm drinking. I know I mentioned that quite a lot, but you know, it is part of the reason why I started when I started doing these streams was I'm like, oh, I'll have a beer and then I'll at the end of the stream I'll be done my beer. That's sort of what I've done, but 'cause I think that's pretty fun. Now let's do capacitor. And I probably will buy more. The capacitor. Might as well buy more of these too. Actually, I have 10 already, I think. It should be fine. Oh. Duck it. Duck it. I said duck. Yes, that was water. I know. I also drink water. There is a fruit fly or something flying in my grass here. Very annoying. I hate it. But yeah, if you have any questions, anybody have any questions, just shout in the chat. I'm gonna use 50 volts because we do want this to be fairly high. Because like I might be doing something that required probably I don't need 50 volts, but I definitely need more than like the 15 or 16 volts, I would say. Just in case. Apply that. Oh, I forgot. Need to in stock, normally stock, and exclude marketplace products. I don't know why DigiKey even has that, to be honest, because I can go and buy it from somewhere else. Like, if you have somebody who has a bunch in stock, I'll go buy it from them instead. Yeah, I think I'll do this one. 50 volt radial. And the main thing we want to look is the 5mm one. Okay. Let's get the manufacturer product. Add all this information into our schematic. Woohoo! And everybody excited? There. And then for the data sheet, I'll actually just put the DigiKey one in here. Now I know it seems odd to be doing this just as a spur of the moment thing, a little bit of drudgery, but it really is good, I find, to add all that information in. Now I haven't gotten into too many times where I'm reordering stuff for boards because I haven't sold many boards myself. They've mostly been for personal use, but still I find it's good practice. Here, do radial 5 pitch 2mm. Let's check. Yeah, lead spacing 2mm. Size dimension 5mm. Heat or height. Heat. Why did I say heat? That's odd. Height. Guess it does have the height, so we could. No, we'll just go with this one. There. Hit OK. Then here, how about let's just delete that. Just sort of re-add this, because then I don't have to redo everything I just did. Looks like you're having some streaming issues, or I'm having issues. I hope that I'm not too blurry. Okay, I think we got everybody, except for, obviously, screw terminals. Let's go terminals. Screw terminals. You know, I just learned that somebody wrote an entire book about connectors. It was on the Amp Hour. They were talking. He was talking to somebody, Chris Bammel was talking to somebody who wrote a book, an entire book on connectors. Made me think I should probably get that book or something, because an entire book on connectors, that could be very useful. And we will go 3 pitch. Might as well go that. In stock, normally stocking, exclude marketplace products. Let's see what we're left with. That one. Let's look, what's this one like? Data sheet. Yeah. This probably is fine. Horizontal with board, that's what I want to. Pitch 2.5 millimeters. Now let's go here. Click E. Footprint. A connector. Banana cliff. Ooh. I don't know if we will be able to find one really nice and easy. I don't know what's going on with this either. Nope. Nope, that's not what I wanted. Sorry, I got a thing buzzing around me. I am actually thinking this might be good. See, it says pitch 2.54 millimeters. Oh, that's the other thing I need to double check, the drill diameter. Ooh. That's... You know what? Let's go back to the data sheet here. They should have it right there. 0.9. Now I know I'm trying to get away with something instead of making it myself. Okay, their drill diameter is 1.1. Add 2.1, that's fine. I think that should actually be pretty good, because 1.1 millimeters 0.9. Yeah. We could also see how much this one costs. Let's see. Let's actually go look at that. It is. This is the part number, by the way, for T connectivity ones. It's just a string of numbers. Go there, plug that in. Ah! It's not what I wanted. Go here, Control C. Try one more time. There we go. Let's see if DigiKey has any. I do, but it's like $5 a thing. Holy. Oh, I've bought it before. So I guess I could probably buy 10 of them. Then that would for sure fit. This one looks good too, though. I think I could get away with buying 10 of those. I'll drop one out of my shopping cart later. I'm sure. If I remember. But yes, that's what I'll use. Ah! Cancel. What the hell? I think I hit W by accident. And we will go here. Yeah, that one. Okay. And I'll just say this MFG part hashtag, or I'll put both the T connectivity one and the other one. For the data sheet, I'll put the onshores, the DigiKey page for this. And I'll just copy and paste stuff over here. Click E. Yeah, that shortcut. Again, I need to get into the habit of saying like when a shortcut's a shortcut here so that I can make these into like nice shorts, YouTube shorts later. But yes, the shortcut to get into the properties is E. So I pressed E right there. You know, if anybody wants to send something in the chat, it doesn't even have to just be a question. You could just say where you're from or something if you wanted. If you feel the need to interact at all. I'm actually having quite fun here. I better save though someday. Electrical rules checker. One could definitely use that. I just know that it probably will say something about something. Annotate, close. I don't know where that bug's coming from. But isn't there a place where I can assign footprints there? Footprint editor. Oh, that's the editor. This is what I wanted to measure things. See here, I'll show you quickly. We go over to the package DIP right there. Yeah. Package DIP. Sorry, I'm talking too much. That's not the one. That's not the one. This one. Yes. Yes, yes. So, now this is the one that we are, of course, using for our OpAmp, the 5th.32. But there should be a measuring tool here. Parent anchor. Talking all dimensions. I just want to measure something. I want the ruler. Where's my ruler? See, this is the footprint editor. I swear there was a way to enter it from the assignment place. Oh, there's the ruler. So now I'll hit there, over there, and yep, that's 2.54. Awesome. Okay. Anyways, let's run that. Electrical rules checker. Where'd it go? See this one always. The V minus not driven by any output power pins, so probably wants me to put in a power flag. Let's just do that. I used that electrical rules checker lots when I first started, and actually since, forget if I have to do it on both. Probably have to do it. Well, not all of them. Since I have made quite a few boards since then, I actually haven't used the rules checker very much at all. What's there? Some ignored test. Global label appears once in schematic. 4 connection points are joined together. Spice model issue. Signed footprint doesn't match. Footprint filters. That means. Yeah, whatever. Close. So that means all of our, we should have everything assigned. Footprint. So now, let's go. Super exciting. To the PCB editor. It opened in another screen. Okay, now let's go. Total warning 0 and 0 errors. So update. There. Yeah. There we go. Okay, there they are. Yeah. Now, I'm going to actually open the schematic in a separate window again. You won't be able to see it, but I will be able to. It's actually in my on my computer, my laptop window, which is very disorienting because it doesn't show up very well. Like it does, it's a smaller window. Now, get those two 10Ks. Put that one there. Now I know you might question my sanity here, but the reason I'm doing this way is that I want to sort of align with how I want the circuit to look. I'm of course talking about how I placed this resistor over here. It's gonna have to go over that way. And then this resistor over here, where it's gonna have to basically go over top of that one's thing. But I have a plan. We'll see if that plan actually works out. It might not, depending on what this looks like primarily. Because, yeah, the one why is that there? Why is that connected? To why is it part of ground net? Oh yeah, because it flips back here. Okay, now that makes sense. Sorry, I was confused as to why pin 2 was connected to the ground net. I figured myself out. So that's good. This 8 will stay there. 4 will be there. 3 goes in to the middle of these two. 2 gets connected to everything. Then, or like gets connected to the ground plane. Then 1 is the output. So what I'm probably going to end up doing is sneaking this one around. Well, actually no, probably sneak it back this way underneath the circuit and over, I think. Let's see. So you probably go like this. You see, I'm also looking at where the different pins are. So the reason why I flip this one around is because it's going to connect to the negative one. So I want to keep that along the side here. And then this one connects, the middle connects to the positive. That way. Does that make sense? Yeah, 2 next to the positive, okay. Now let's move these capacitors into place. Sorry if you can probably hear my furnace going now. Sorry if that's causing distress. I found a mistake. I have found a mistake. Yes. Very bad mistake. So remember, this here is going to be our negative voltage. This is our ground. This polarized capacitor is going to blow itself up. We have to flip it around. There. That's better. This one. Yeah, no, that's both good. Yeah. Good. Sorry about that. So now, what you do when you find that, you go update PCB from schematic, and it's going to say reconnect C2 pin from negative to ground, C2 pin 1, and then C2 pin 2 from ground to negative. So update, close, and we are good. Okay. Now for these, so that'll be good, I think. This, I can flip them either way, I think, but I'm going to show you something. I think there's an align. Where is it? Align, distribute. Align, horizontal, no, Control Z. Vertical center, there. So now they'll be same. Guess I might mess that up there. That. We'll move this guy in. Try to have it sort of there. Then we can probably move them closer still. Closer still. Closer. 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 I'm sorry if my closer repetition is bothering somebody. This. That, and I will go again. Line, distribute, vertical center. Not overly symmetrical. I don't know how much I want to put in to get in that correct. I think that will be fine. So click save, and now I want to enter board setup. Where do I go? Predefined sizes, constraints, teardrops, classes. That's what I want. Default. Power, I'll say. Clearance 0.3. The main thing I want to change. So I'm going to double the track width. And I'll just put in the rest the same. We shouldn't need any vias. Because, well, it's not a very complex thing. And we'll just put one for ground. We'll put in more clearance there, I guess. Sure. That's primarily, I'm going to be making a ground plane. We might as well give it lots of clearance. Assignments. This type started negative. Yeah, it doesn't seem to listen sometimes. Think what I had to do last time. Try this again. Global labels. Negative. It's actually overly hot in my garage right now. I think I should turn down my furnace. Click save. Now I'll go back and I will update PCB from schematic. Close. Then let's go to board setup. That one's there. Board setup. And we'll assign that one B and D. Okay. Yes, what we can do. I don't know. I think there's something wrong. There's a bug or something. I wonder if I got a minus VCC. Minus VDC. We can use that instead. Yeah, it's definitely getting fairly hot in here. Let's go back. Update from schematic. And now we will go add now I'll just say power. See, I think there's something weird going on. I'll have to Google that after again. I've had that happen to me before. Let's just we'll just use this positive VDC and negative VDC. Thank God my furnace just quit there. I should turn down my furnace in the garage here. That got way too hot for a bit. It is quite a bulk furnace thing. Like it's a garage furnace, right? So it's all of a sudden it will get really cold on this side of the place, and then it will get like hot. Okay. So now let's go here to board setup, and we will add plus VDC, and that goes there. And we'll put you to the power. There we go. So this should actually be rounded up, turned around. Because you see the plus VDC was over here, should be over there. But anyways, let's just start wiring. Oh, we might as well do. We will actually. I'll click that, click U, click delete. Click that, click U, click delete. Now, what I am thinking I'm going to do is on this side, like right here, up, down bit, there, and there, I'm going to make a plane, filled zone. Actually, what I should probably do first is create a Edge.Cuts. Actually, I'll do that first. Yeah, here. To create the Edge.Cuts, I'm also gonna make my grid bigger. Maybe not that big. That big? Yeah. This big. The reason I do that, primarily because then it's much easier to decide where to put things. When you have a grid made. There we go. So now that's made on Edge.Cuts. Let's just see where we are at for board size. So it's going to be just over 2 inches long and an inch wide. I'll think about it. Again, I'm not planning to put this into production or anything. This is more just for... I'm going to probably... I need at least... Here, I'll set my grid sets down low again. I need at least... It goes down there. Oh. That's too small. Yeah, right there. Yeah. I need at least 2. Cancel. Need to switch to the front layer. Need at least 2 because I'll use 1 at work. I have a day job, unfortunately. I mean, I guess in some ways, very fortunately, that I have a day job. Some people don't. You always have to remember that even if you don't like your day job, there's probably a lot of people who would like to have it. But anyways, I have that and I do some electronics there. And I'll probably just gift one to them so that I can use it. See, I already have an issue here with my ground overlapping. Let's go here and see if I set the clearance stuff back to what it was. If it goes, or if maybe I will have a problem. Yeah, that seems okay. But anyways, let's hit B. Let's fill those zones. We'll probably do the ground one on the back plane, just in case you're wondering how I'm gonna do that. I think that's what I'll do, is I'll just do it on the back plane. So that looks nice. Let's do another filled zone for the minus VDC. Why don't you say? We'll start at about the same place. Minus VDC. Okay. And then here. That fly is still bothering me. It's probably because I have a bunch of empty beer cans in my grass that I have not taken care of yet. Yes, I know. Most of my complaints are things that is my fault. I'm aware of this. I have the power to make my life happy. I always forget, there's somebody who told me once that they don't, like, having these hard lines isn't very good. It makes sense that they probably wouldn't be. I wonder how I should make them smoother. Maybe I should Google that sometime. Anyways, let's go and make the rest of these. There. No! We have to edit this one. Ah. Troll's head. Probably go here. Yeah, just go there. Then we will move you there. Let's all go like that, I guess. Yes, you did. Frick. If you haven't noticed, what I'm upset with myself about is I didn't get this guy here. I also didn't get this guy here. But now let's try to remedy that situation. We will gonna have to move that up there. This one go down there. This go up here. Now let's see. I'm thinking maybe I should just redraw this. Yeah. Let's just redraw it. And we will just go all the way like this, like one there, and there. I'm just gonna put in a bunch more than I did last time. Okay, there we go. That looks better, I think. B. Oh, yes. Okay, I think that looks a lot better. Let's just add another one here. You like that. That will be a ground plane. Yeah, let's just redraw this one too. Because you see what happened? I need to get this here, but I can't because I put things in the way. Of course. I thought I'd be on my second beer by now. Kind of shocked I'm not. Go there. Then here. This one I'll just do like I did the before, basically. Will be the next part. I'll start just like really. Might as well avoid putting one near the top of this ground. And I'll go here and I'll get you in. And I'll have to come up here and get you. Like that. Oh! I think that just looks golden there. Don't you? Hey? No? There we go. Okay, click B. Now, who thinks that looks like a beautiful circuit? Nobody? No, that's too bad. Go there. And I'll just put another one in to connect them a bit more. And I think the rest is just ground. So we will do another filled zone on the back plane. And it's basically gonna be the whole freaking board. Effectively. Because, why not? Okay, now let's save that. Run the design rules checker. Nice. Okay, the last thing I want to do while you're here is I'm gonna add a mountain hole. Ooh, that's a big mountain hole. No. Let's add a smaller mountain hole. Now, the reason, one of the main reasons I want to add this is because I'm probably going to make a new video showing this. Because I made a video earlier in my life that showed this, but it doesn't work for every board house. But anyways, I'll just run through what I did. You press A to get to the footprint place. Then I typed in mountain hole up here. And it showed up and I got this list here. And I just select that. I add it. I'll put about... Where was I putting it? Yeah. That's good. And again. There. And I think mainly I need to just move in this. Okay. Now let's run the design rules checker again. Ah. I'll just delete that. We don't need that on the silk screen. Run DRC. Okay, close. Now I just want to go to my 3D viewer. Yes, that looks pretty good, I think. So I'll probably get those ordered at some point. But yeah, I think that I'm gonna leave that where it is for now and probably go up to bed. Thank you for everybody who tuned in. If any of you have any questions, maybe just you could send them in the chat, or I'll be monitoring the comments for sure. Yeah. Thank you for tuning in, and again, just for those of you who may not know, the circuit that I was making basically takes a single power supply, so like my bench power supply, and it splits it into two power supplies, one positive, one negative. And I found the circuit on, let's just go to that wonderful site again of the YouTube. I mean, this one.
Rating, you should probably.
What happens if my dad starts Tai Chi tomorrow?
No. Let's copy this. Put it in the chat here. So this is the website. I'll just double check. Yeah. And it's using OpAmps, and it's right at where I sort of was.
Rating, you should probably put a heat sink on.
Yeah, and it talks about how you want a heatsink too, which is something that I should consider. I hope you learned something. In particular, like I should go back to the data sheet again here. But that's maybe one of the main things you should take away, as always, is that looking at the data sheet is very good. And yeah, thank you for tuning in, and I hope you have a good night.